This is BSA by Design, a podcast about transforming healthcare, educational, and research facilities through expert design and insight. I'm your host, Brian Moore, and thanks for joining us again. In this episode, I talk to members of our fantastic learning and discovery team about renovations of lab buildings on higher education campuses and the revitalization of these buildings. Before we get to our conversation, let me introduce our guest. Kay Townsend is a senior lab planner. Kay earned her Bachelor of Architecture from Ball State University. She has been a member of the ACE Mentor Indiana Board of Directors for 18 years, and Kay has been with BSA for 22 years over her career. Steve Brupbacher is the principal at BSA and lead AP certified. Steve is located in our Austin studio and received his Bachelor of Architecture from the University of Texas at Austin. Steve has 25 years of experience and has been with BSA for over 7 years. Derek West, who was our guest on episode 7, What is Discovery, has been with BSA for nearly 4 years in the role of principal, where his primary market is the discovery market. Derek is based in our Raleigh studio. Prior to joining BSA, he was a principal with Lord X Sargent and a designer for KSS. Derek received his undergraduate degree in Architecture Engineering Technology from the University of Memphis and his master's in architecture from the University of Virginia. Welcome to the show, Steve, Derek, Kay. Appreciate you all for joining us today. Derek's been on the show before and shared some of his passion for architecture. It's kind of a rite of passage for first-time guests to share with us how they got started and where their passion comes from. So, Kay, how about you go first?
Well, I did one of my first jobs, my first lab projects at BSA almost 25 years ago. It was a major renovation of a project in the medical science building on the IUPUI campus, or IU campus, I guess now, downtown, for the School of Medicine. It was a combination of research labs and teaching labs, and did I learn a lot from that. It was a 1950s building that we were trying to bring up to date. So I really feel like I cut my teeth on that and learned just about every pitfall that there probably could be in a renovation project. But, what I really love is taking these spaces and creating, great labs for people to work in every day.
That's awesome. Steve, how about you?
Yeah, well, since joining BSA, I've been involved in higher ed and lab renovation markets. And that work has really allowed me to find my passion in creating these environments that make day-to-day life better for the individuals that use those spaces. I really like to help people, and that work really gives me a direct connection in that realm. To me, lab renovations in those higher ed spaces really give those people a place where they learn, grow, and create those advances. That'll be here for the next decade, century and onward, and that kind of work really motivates me.
Excellent. Well, let's bring Derek into the conversation now too a little bit. So to jump into our full-on conversation about renovating and revitalizing lab buildings on higher education campuses, I know you're all adept and you all have experience in renovating these existing lab spaces. What are some of the main drivers behind the current trends of renovating and revitalizing lab buildings on college campuses?
It's really interesting. We've got a lot of things I know that we want to talk about today, but we could probably spend the whole time just talking about drivers and nuances between them. I mean, fundamentally, one of the major things that is driving the work today is that institutes are instructing and teaching learners differently than they did even 5 years ago. That's part of it. The way investigators are doing their research, who and how they're collaborating with their colleagues also continues to change. So these older buildings are not even close to being optimal to accommodating how this important work is happening. So I guess the driver or drivers that come out of that dynamic is meeting current needs and anticipating future needs are two kind of prevailing things. Just from my standpoint, a couple of other things that immediately come to mind are the need to support both in-person and remote learning at the same time. Every single lecture now is captured. And so we have to create spaces that accommodate that. And then finally, for me, this is true about every campus that we work with. All space on campus is really precious. There's not enough of it anywhere. And so it's all premium space. So every chance we get to try to create spaces that can do double duty or are at least fairly easily adaptable to do something else down the road, because things are going to continue to change, is something that all of our clients are looking for us to help them with.
Well, yeah, I think one of the interesting things is a lot of your campuses can't really afford, maybe financially or even classroom wise, to do like an entire floor or an entire building at one time. And they somewhat piecemeal a project together. So then there's always that constraint of how do you continue having classes in a building that's in construction? How do you ensure student safety, while they're in a building under construction? So there's sort of that other nuance of complexity, I think, that it adds to renovations in higher education institutions.
Yeah, and I think in my area, and Derek touched on this a little bit, a lot of these existing lab buildings were built, a long time ago, and they met the modern labs of the period, but they're not really keeping up with the trends and what is being seen in that space. Currently there's a lot of issues with systems being past their usable life. So things like, mechanical systems and things like that, and even electrical systems that need to be upgraded. They don't meet current code. So they're running into issues where, as research is adapting and changing, the spaces can't keep up with the needs that are required for that research. And another big factor in our area, there's a bit of a kind of a twofold thing. There's a lot of new lab spaces being built. And so people that are in the old lab spaces want that. They see it and they're like, well, I want my space to be as nice as this. And I want these upgrades. I want this flexibility. And I don't want all of this old stuff that I've been using for the past 20 years. And in that, there's a drive in some of these institutions to attract the best and the brightest researchers and students. And if they're not keeping up and they're not building these nice, new, modern research spaces, people don't want to come here. They're seeing this old space that's got all this wood and the old black counters. And, they're like, why would I want to go to that university?
So everything that you guys are saying makes a ton of sense. Obviously, I'm not in the architecture. I mean, obviously I work for BSA, but I'm not an architect like you guys. But my oldest just graduated college. My second oldest is a freshman in college. And it's funny, you don't see a ton of new universities, right? So when you step on a lot of these campuses, and it, founded in 1888, and it's like, okay. And they've done a great job at trying to keep whatever architecture and feel that their campus has. But to your point, you can't just build a new building every single time you want to. So there's a lot of renovation that needs to happen. And Steve, to your point, I mean, I guess 20 to 25 years old sounds old, probably not to all of us on this podcast, but I know there's some buildings, from 60, 70 years ago that are in need of that upgrade. So Kay, how do you approach assessing an existing lab building to determine its potential for renovation?
Typically, when we go in and assess an existing building for renovation, you would like to think that, or at least hope that the structure is sufficient if they've been using it as a laboratory facility, meaning adequate loading capacities and such, that it might have a decent structural bay system for more open lab bays, and adequate floor-to-floor heights. But that isn't always the case. And sometimes you have to get very creative in the way you approach putting modern systems in sort of a non-modern building. For example, when we did the medical science building renovation all those years ago, they literally had like an 11-foot floor-to-floor height, which is almost impossible to get ductwork and above ceiling installations into that space. So we came up with a solution where we ran the ductwork in chases down the exterior of the building and then fed into the lab spaces so that they could reutilize those spaces as functioning lab spaces. Sometimes you evaluate a system or a building and it needs to be more office space instead of lab space. It just fit with the modern technology and MEP systems that we see that are required for modern labs.
That makes a lot of sense. I mean, this image of these buildings that may have been built, 60, 70 years ago, maybe they've been remodeled inside. So you've got this shell that you're trying to work with. And Derek, what are some of those common challenges that you encounter when you're renovating older lab spaces to meet some of these modern research needs that Kay was touching on?
Yeah, it's interesting. It kind of depends on how old they are, right? You said 60 or 70 years, and indeed we could be renovating, probably not for the first time, but the second time a building that's that old. But, after a building's 50 years old, it's kind of up for discussion if it's considered historic. So,
good point.
There's all sorts of interesting dynamics that can come into play there. But I would say that most of what we're seeing in academic science research and teaching nowadays is 70s, 80s, and 90s buildings that are kind of coming up for renovation. So there's a different set of challenges and constraints that we're navigating in those. One thing that's still true, though, is most of those buildings, the university really doesn't have anything other than PDF documentation of those buildings. So there's a whole effort dedicated in the renovation process to documenting those to a standard that we can create a set of drawings to convey to a contractor how to build it. So that's just one of the challenges. I actually think that's really fun to kind of get in there and figure out how these buildings were built, and were they actually built the way the documents suggested that they were, and all that. It's part of our job to do that due diligence.
Not to throw you off track, but I have a question. And I may be stretching here, but is that a Matterport sort of thing? Like if they don't have, will you ever lay out like that?
Well, what you're touching on there is one of the really, now I would say, critical pieces of technology that we have and we employ every week in our work, which is a device that you can set into space, and it literally scans three-dimensionally. We move this through the space, and over a series of dozens or could be 100 scans, we can document the inside of a building with a lot of specificity, with confidence in where things are said to be. So yeah, I mean, we use that all the time, and that's super helpful. But we still have, that doesn't show you, it doesn't have X-ray vision, right? Right? It doesn't show you what's in the walls and where the structure, what's really, how the structure was really built. So we spend a fair amount of time working to figure that out. Another thing that's always a challenge on these projects is, and we've kind of touched on it a little bit, is just how does this modern or current program, work with the existing dimensions, the existing pathways, all of that stuff in a building. So that's a challenge. Kay touched on this a little bit, but rarely does a university have a whole building or a half a building or even a floor vacant to shift people from around. So most renovation projects have some aspect of swing space, enabling projects, all in an occupied building. Other common challenges that I can think of, the budget. I mean, the budget, especially at these larger institutions, budgets are set out 2, 3, 4, 5 years in advance. The state system in North Carolina has a 6-year plan that they work on, and budgets that were made in 2018 for the 2022 or 2023 project post-COVID weren't even close.
Right.
So the budgets are often difficult to navigate. And within that, we have to kind of help the users and the institution figure out, are we going to kind of button up this building to help it, limp through another 30 years or so? Or are we going to go to the extent that, this thing's going to be energy efficient and flexible and whatnot over that same time period? So all of those things are challenges, I would say, that we deal with.
Let's talk about some misconceptions that there might be, Steve. Are there any common ones about renovating lab buildings on college campuses?
Sure. And I think kind of jumping off with some of the items that Derek was saying, I mean, a lot of times you run into these things and people think they can be done easily or very inexpensive, and because they're used to renovating classrooms or other office space, and that is definitely not the case with lab renovations. They are very complicated, and most interior renovations, but they always seem to reveal something unexpected. Usually these buildings, you're in there renovating it for a reason. And usually these buildings are struggling to keep up to meet minimum code requirements for outside air or exhaust or whatever. Right. It always snowballs into some large scale system renovation that needs to take place that aren't always identified or anticipated at the beginning of a project. And, these spaces are, premium spaces. They're some of the most expensive renovations and spaces on campus. And, they really take time and take a lot of, budget in order to do them properly.
Kay, I wanted to ask you, just because, as Derek mentioned, there's a conversation sometimes that comes up, are these historical buildings? So if they are, how do you balance preserving the historical or the architectural significance of a building with the need for a cutting edge lab facility inside of it?
Well, I think it's always interesting to see that dichotomy between the historical components of a building and the, I guess you could say, somewhat futuristic lab designs. Sometimes it looks pretty much like that if you get white benches and, all the bright lights and everything. It looks very sort of futuristic. But I think most of that historical presence would probably be in the exterior. And actually, Steve could speak a little bit to Anna Hiss and what we did with that project, So, really when labs are more than about 20 years old or so, there's not a lot of interior stuff left that is of any significance, stairways maybe, but that isn't a lab component. So, much of the interior of an older building is going to require a complete gut to bring it up to code and to be sufficient for lab use.
Yeah, really good point, Kay. Steve, can you share with us a little bit about the Anna Hiss project? I know a 1930s gym that was converted. Share with our audience a little bit about that project.
Yeah, sure. It was, it was the original women's gymnasium on the UT Austin campus, and one that built in the 30s, going to convert it into a modern robotics lab building, which seems like a foolish idea at the time. Right?
Yeah.
Seems like a terrible idea. But, that building in and of itself had a lot of kind of emotional connection for people on campus. And we really identified quickly that, that exterior, the vision, the, iconography of that exterior of the building was something we needed to keep intact. So we were very careful that we maintained that exterior, we maintained that original look of the building. And then we really looked at the interior as to where we could kind of divert away from that a little bit if we wanted to put in some modern finishes or really update things. That was where we would do that. We kept some, some highlighted areas, main entry, stairs, things like that, where, some of that historical pieces were still in place. We maintained that in a way. We didn't want to go in and cover everything up and make it, this, clean white box or anything like that. So we were pretty careful with how we treated it. I think probably more unique than a traditional lab space since it was a gym, right?
Right.
You get a gym space and make it a lab. What are you going to do, right? That gave it its uniqueness and kind of its flair to a certain extent. For us, just showing off some of those original historic pieces really gave that project its character.
Yeah.
And really gave the robotics group kind of their own home that, didn't feel sterile. Right, it had a lived-in quality and really shined through for them.
Well, and I'm assuming, Kay, I'm going to come back to you for this. The importance of flexibility. How important is that, especially when you're dealing with a renovated space?
Well, I think flexibility is it is the trend word. It is the fad word. It is also the word that really kind of drives everything when it comes to labs, because there are too many unknown changes from equipment, from the type of science that they will be doing, from the subject they're teaching in a lab, So we have to be able to adapt to that quickly so that universities don't have to go back in and re-renovate a space, so that they could be adaptable and flexible for various classes and such. Like I've told some clients, you want that room, whether it's a teaching lab or what, to be used almost every hour of the day. You don't want it to be designed for one particular class and set empty, like 7 hours out of the day. So really, flexibility and adaptability is really where it's at in getting them more bang for their buck, honestly, in the lab usage.
Let's talk about another ability word, sustainability, and some of the sustainability goals. How do those factor into lab renovation projects?
Well, a lot of times they think about sustainability being energy modeling, We did a study with Purdue years ago about how much water they use doing aspirations, and so they went to a vacuum system instead of using water. But you always think about it being very high level MEP associated. But there are a lot of sort of low cost, no cost ways to make your laboratory sustainable that really don't have to do with the building itself, but more your actions. Think about green chemistry. Chemistry is getting more green using less chemicals. A lot of classes are doing sort of their chemistry synthesizing on computers now instead of in a hood or whatever.
Right.
So, think about going green. Think about your cleaning products that you use in a lab. You could do a green cleaning product. Implementing a recycle program within your lab. Many of the vendors and the suppliers, they have recycling programs for pipettes and packaging and all of that. Powering down some of your equipment when you're not there using it are just a few of the kind of items that you can do within your lab. And, it's not really those sustainable, like you would think about LEED and,
Sure.
getting your LEED credits and everything. They have really kind of nothing to do, with that. You could even look at leasing equipment or releasing equipment for more energy efficient equipment. They do have programs that they do freezer competitions on saving money with your freezers, and the power that they draw. Yeah. So, and you can also look at it as being operationally sustainable for your people, making it more efficient for them to work in a space, So you can think about operational efficiency in regarding with your staff rather than the building.
All those things sound super innovative. And when I think of sustainability, I think of some sort of innovation, but there are other innovative solutions, I'm sure, that help do lots of things. So what are some of the innovative solutions that you've implemented for say, maximize space efficiency in existing or renovated lab spaces?
Yeah. So, when we look at planning a lab renovation, we kind of look at all of the departments or the groups that are going to be housed, say, on the floor, and we look for sort of some commonalities. Do they each need an autoclave room or a glassware room? Can they be centralized and shared? So not only are they utilizing that space more often by all the groups using it, but you don't have to purchase as much equipment. And then some of that space that's saved by not providing that for each group can be turned back into lab space.
Yeah.
Okay.
Anybody else got any other ideas?
Yeah.
How have you found the sharing of space between researchers going over in the past few years? This is something we're touching on a couple of projects where we're trying to get more shared space. Researchers share equipment and share, like you're saying, if they all have can use one autoclave, it's less equipment and it's less space. How are they, I guess, accepting of that sharing of those space and not being so, historically researchers and higher ed can be very, really.
There you go.
I'm curious how that's been going over.
It actually works really well. And I do feel like over the last 25 years that I've been doing this, we have seen a more interdisciplinary approach to most researchers. A teaching lab is quite different, I think, in that that the university supplies a lot of those resources, to the classes. But I think from a research perspective, they're not as territorial as they used to be. They're seeing the value of collaboration and interdisciplinary approaches to their science to where it's not such a taboo anymore, I think, to share. When you have those sort of casual collisions, at the, at the equipment room or something, and you just start talking to another researcher, you find that, they may have an idea that you could use in your science, and it's really beneficial. I think those days of being territorial are somewhat gone for the majority.
Yeah.
Interesting. Steve, this just popped in my mind when we were talking a little bit ago about, the conversion of this gymnasium and all these spaces are, existing buildings. So there's got to be some sort of safety around there as you're updating them. How do you address safety concerns when you're updating older lab buildings to meet current standards?
Yeah, that can always be a little tricky. I think it gets into the systems and kind of code requirements. A lot of the older lab buildings met the requirements of the time, and those requirements may not be acceptable anymore, right? And as research and things have changed within those lab environments, maybe they haven't been upgraded to keep up with those changes as well. So, we run into some things where, an older lab may have an open return plenum, right? That's not great. Or no outside air or fresh air requirements, right?
Yep.
Things that seem kind of, against what you would do nowadays. So it's important to get those areas upgraded and get those things up to date so that you are creating a safe space for not just for the people in the space or the researchers, but the research itself, because a lot of that can be very time consuming, costs a lot of money, and any little bit of kind of bleed of maybe a toxic chemical into this clean space can ruin it. And that's just, you can never get that back, right? So you have to be very careful and really diligent about updating those requirements.
That's a really good point. When we're talking about some of these buildings, again, I guess they could be from the, like Derek said, 70s, 80s, 90s. Those buildings were probably, I'm guessing, not built for current technology and equipment. So how do we incorporate those new technologies and equipment into these lab structures when we're doing them?
I think one thing that's really kind of cool is, in a 70s lab building, if there's fume hood equipment in there, for example, it might be pulling 110 CFM or 120 CFM, that's cubic feet per minute, through the face of that fume hood, which is a lot of air. And if you have 50 fume hoods in that building, it's a whole lot of air. And so kind of getting back to, Kay's topic a minute ago of sustainability, some code requirements and our understanding of energy consumption and how buildings perform and whatnot are going in a direction that things are getting more conservative. In other ways, it's not. So, for example, fume hood technology now, we might be designing to 70 or 80 cubic feet per minute as opposed to 110 or 120. So not a fraction, but 60% of where we were. Or we might even be recirculating air from a fume hood back into a space because we've got a filter technology that enables us to do that, radically changing the amount of outside air, makeup air that's required for a building. So it's not necessarily linear is what I'm saying. And our technology is one of those things that's helping us at the same time make buildings safer, but also make them more energy efficient.
Yeah. And now I'm thinking of something you mentioned earlier as you talk about all these different things, which is budgets can sometimes get set years before. So how do you discuss the cost considerations with your clients when you're talking about renovating versus maybe perhaps building a new building?
Yeah, that's like the most fun thing to talk about is money, right? How much these things cost, not
right.
Well, I kind of feel this is kind of, in some ways, kind of dangerous territory, right? Because you almost have to date stamp this. So, and whatever I say next is not going to be relevant 30 days from now.
Right.
So when we're talking about money really matters. So, Anthony, how much is a lab renovation cost? How much is a new lab building going to cost? There's dozens of factors that go into, getting close to the right answer on this. But having said that, just to try to kind of put some brackets around it, if we're talking about an academic institutional building that's geared towards a combination of teaching and research, let's just sort of say that's what we're talking about. We're not talking about a building with a very large vivarium in it or super high containment space like a BSL-3 or even like quantum physics or optical spaces that require super tight temperature and humidity control ranges. We're talking about, kind of more general science instruction and research buildings. I think we could kind of break this into sort of 4 categories. And we every year do dozens of projects in all of these categories.
Okay.
So the first one, the least expensive, the $1 sign might be, if we're really talking about giving a building a face, a lab building a face that might include addressing some code issues, accessibility issues and things like that. but the building's generally in compliance. So we're replacing casework, we're replacing lighting and finishes. Not a lot of mechanical, electrical, plumbing infrastructure. We might be in the $180 to $200 a square foot range. That's probably as low as we can say that we can go. The next level, and I can give a real world example of this that just finished construction. If we were essentially keeping the floor plan layout, but we're taking everything back to those walls and back to that structure, removing existing casework, finishes and whatnot. Generally the building MEP systems are good, but we are redistributing all of that stuff in that renovation of, let's say, that floor. We're probably going to be more in the $380 to $400 a square foot range. Okay. The next sort of level of intervention might be gutting that building or gutting that floor all the way down to the structure. So we're taking out partition walls. This is probably more common in terms of the work that we're doing, because these 70 or 80-year-old or 70s or 80s buildings were much more kind of compartmentalized, a lot of smaller spaces. And now, the flexibility that Kay and Steve both have talked about, we're looking to create larger spaces with multiple modules of research space in that, so that they can expand and contract research teams easier. So in that instance, we're taking the building back to its core structure, putting in new walls, generally new mechanical, plumbing, electrical systems, lab casework, lighting, all of those sorts of things. We're more in the $500 to $700 per square foot range. And a real world example of that we just did 2 months ago, and that's in construction now here in North Carolina, that bid at $540 a square foot. And that's about what we anticipated, about a 50,000 square foot project. New construction, it's tougher to kind of put a hard number on that. So I'll give you a larger range, but a new lab building is likely going to have some, campus infrastructure requirements. There's likely going to be some site work going on. You're likely going into the ground. So there's earthwork and a lot more structure involved, but you're probably more in that $600 and $900 per square foot range.
That's a really, really good breakdown. Thank you for talking about it that way too. So I want to ask Steve, and I don't like the word future-proof necessarily, but how do you renovate lab spaces to accommodate evolving research needs?
Yeah, sure. And I think, Kate hit on a lot of these items earlier, and kind of, flexibility. Obviously, that's a huge one, right? Everybody wants a highly flexible lab. We want mobile benches and flexible layouts, so that, as research evolves and they bring in a new piece of equipment, they don't have to do a whole new renovation to accommodate all of that stuff. And they really want that adaptability kind of built in, so that, it can just adapt and change as they change. So I also think some of the stuff that Kay was talking about, like the shared spaces, I think shared resources, I think that really helps as well, so that, your lab is your lab, maybe where you have a lab support space that's there for you to, where all your equipment is. And maybe that's designed in a way that equipment can easily be moved and changed and without disturbing what you're doing in your actual lab space. So I think those sorts of things really help with this kind of evolving research needs.
That's a good point. And Kay, you were talking about earlier, and I think Steve had asked you the question, users are starting to play nicer with each other. And now we're talking about shared space. How do you balance the different needs of different scientific disciplines when you're renovating these spaces?
Well, as we've mentioned, sometimes, even though the science is different, some of the equipment might be the same. Different, biomedical engineers, or an analytic chemist might need a fume hood, but they don't need a fume hood all the time. So looking at some of those shared spaces, pulling out some of that equipment, I think it's probably one of the strongest ways of doing that. I think at times there are certain spaces that need to be separate for them. If you're doing a laser lab, you probably don't want them adjacent to a vivarium, or something. So I mean, there are certain times to keep functions separate, and certain times that they could be shared and reduce cost for all groups.
Coming off of that, then, Derek, how, with these different user groups, you've got faculty, you've got researchers, you've got students, how do you involve them all in the renovation planning process?
Yeah, I actually think for me, this is probably one of my favorite parts of what we do.
Other than the money, right?
Other than talking
Other than
about
talking
budget.
about budget.
Yeah.
Yeah. This is
Yeah.
actually your favorite.
Love being the bearer of bad news. Yeah. No, it really depends on the institution, because each institution has kind of a different culture around who are the decision makers, to what extent are they the faculty versus administration, how collaborative are the faculty encouraged to be or want to be, all those sorts of things. This kind of goes to the last thing Kay was talking about as well, regarding, sort of merging or blending different scientific disciplines. I think the most important thing that we can do is, in this regard, is look at ourselves as kind of moderators and consensus builders. We have to set up groups. We have to get our clients to allow us to set up groups that are both siloed at times, because we want people to be able to say what they really think. Like, if there's a particular department that struggles with whatever, the politics or another department or whatever, we want to hear about that, because it can kind of play into the dynamics. At the same time, we want them to hear what each other are doing, what their goals and visions are, and what their challenges are, because I've seen the light bulbs come on in these meetings where seemingly polar interests or polar approaches or whatever, when one researcher just describes what they do, they're like, oh, I use that same thing, but like Kay was saying, I only use it 2 days a week or something.
Right.
Suddenly, now we've realized that we can eliminate a whole room or series of rooms from a program and use that money or that square footage for something else. So talking, getting people to just kind of talk through what they do, why they do it, how they do it, is critical. And unfortunately for everyone, probably, but for us from a fee standpoint, we can't do that just once. Design is an iterative process. And a lot of times folks will be in these meetings, and it's kind of like that old Seinfeld episode, where George Costanza was like, oh, I should have said, they'll get back to their office and like, oh, I should have said this, or I should have brought up that. So, we kind of want to do this multiple times so that people have that chance to participate and sort of advocate for themselves, but advocate for their colleagues, as well. I think the end result that we're going for is that while it's incumbent to realize that we're designing a space for an institution that's going to last long beyond any of these particular individuals, we at the same time want them to feel like they have ownership of it, right? Like that it is something that they can be proud of, that, as Steve mentioned earlier, that they can recruit colleagues from other institutions to, and that students are, going to come in and be like, hey, I want to learn about physics here, kind of thing. So I think communications is key, and getting people to talk and realize that they're probably closer together than they are further apart.
Yeah, I know you're pretty passionate about that, all joking aside. And those light bulb moments in conversations are kind of the thing that jazz us all up, if you will. And not to make a bad pun here, but speaking of light bulbs, Steve, I wanted to ask you about energy efficiency. How do you approach improving energy efficiency and reducing, that environmental footprint in existing lab buildings?
Yeah, sure. Yeah. Speaking of light bulbs, there you go. Technology, I think, that plays a huge part, right? The advancement of lighting, for one, right? We're now at LED lighting that just takes a fraction of the energy of even the fluorescent or the, standard lights from before that. That always helps. Those are easy kind of ways to do things. I think in general, you got to meet energy code requirements that's built around being energy efficient. I think, again, with the technology advances and the equipment that are in these lab spaces, the fume hoods, like Derek spoke to earlier, lower flow fume hoods over what we've been using in the past, things like that, all of that helps. And I think as these things build on each other, you're getting a more efficient and a more energy efficient space as you're doing just your standard, renovation that you could do in any space. As lab spaces are also more expensive, they are probably huge energy users. They use a lot of mechanical, they use a lot of electrical. So, any little thing that you can do to offset that helps.
Yeah, and you mentioned technology. Kay, do you want to dive in a little bit more on what kind of role technology integration plays in modernizing some of these lab spaces?
Sure. So obviously today's lab is very connected. We either through cabling or we're seeing more and more wireless, but there's, with that growing analytics that I talked about earlier, part of that aspect aside, you see the technology interface has to be really substantial for that data transfer. Some of those files are huge. And so, you have to account for that. Plus, we see, many pieces of equipment being connected to like the building automation system. Refrigerators are connected and backed up and all of that. And as you heard Steve and Derek say earlier, this research is valuable. If it were to be lost, whether it's, a sample or data or animals of some sort, if that is lost, it could, be irretrievable, invaluable, and just almost impossible to replicate. So I think,
Right, sure.
yeah, technology is just extreme in the lab environment. I think, not sure extreme is the right word, but it
Very prevalent, it sounds like.
Yes, absolutely.
Well, let me finish with this, and I'm going to jump around to each of you. I like to consider myself somewhat of a futurist. I like knowing what's coming next. So let's close on looking at the future a little bit. What trends do you each foresee in lab renovations and revitalizations, let's say, over the next 10 years, next decade? Okay, we'll start with you.
I really think that we are going to see continued open labs flexibility, but I really think the interdisciplinary approach, and I think the approach of bringing corporations into the campus to team with researchers and students is probably going to continue to grow. It's valuable for the corporations because they get a link to potential interns and future staff. They get the ability of these bright minds to work on things for them too. And I really think that interdisciplinary and corporate partnership is probably where I see a lot of that going.
Oh, that's good insight. Steve, how about you?
Yeah, I would mirror, flexibility, shared resources, shared spaces, things like that. I do think a trend we see is a lot of these researchers in these older buildings are used to these dark corridors in a closed off lab space that has no windows, no natural light. And whenever we talk to them, one of the first things they say, "Can we get some windows? Is there a way I can get some natural light into my space?" So I think the days of those kind of old, dark, dingy lab spaces may be kind of coming to an end, which is a good thing. I know there's spaces that require that, right? Laser labs, you don't want that, bouncing through windows, things like that, right? That they need kind of a dark, closed off space. Anything that can have some exterior windows, can have some natural light. I think they really want it and they really need it.
Derek?
Well, Kay mentioned a little early on that a lot of the functions that used to take place in a wet lab can be modeled now. And so I think we're going to continue to see a shift from labs being upfit for more piped services, gases, water, liquids, things like that, just to more power and data. The instrumentation, the equipment is all requiring more power. It's all connected to something so that whatever information it's gathering or analysis that's doing can be fed to computers or other pieces of equipment elsewhere. As Kay mentioned a little while ago, it's got to be fast. It's got to be able to transmit a lot of data at once. And data storage is a huge issue. So I think we're going to see labs become more and more and more and more electrical.
Very nice. I like that. In fact, I might put a little breadcrumb in at some point in the future on this podcast. We're going to have a conversation about wet labs. So I'll just leave our audience with that. Thank you guys so much for joining. This has been a great conversation. I appreciate it.
Thank you.
Thank you.
Thanks again to Derek, Kay, and Steve for joining me on this episode of BSA by Design. You can connect with them on LinkedIn. If you're interested in learning more about BSA Life Structures or our learning and discovery practice, we encourage you to visit our website at bsalifestructures.com. There's a link in the show notes to contact us for more information. Be sure to subscribe to BSA by Design on Apple Podcasts, Spotify, and YouTube Music so you don't miss an episode. And we've got more content and project stories to share on social media, so be sure to follow us on LinkedIn, YouTube, Facebook, Instagram, and X. That's going to do it for this episode. Join us again next time on BSA by Design.